Hi everyone, we are looking to finish today the rest of lesson 14.2 and look at the bottom piece here, which is recognizing trig ratios to complete reference triangles. So yesterday we spent a lot of time looking in part 1 about converting between degrees and radians and finding the spots with the radians on our coordinate plane just like we have with our degrees. Now today we're going to skip through and start actually on page 194. So skip over some stuff we didn't do. And on page 194 we see here the vocabulary word reference triangle. And kind of like coterminal angles, reference triangles are something we use a lot in this unit. And a reference triangle is always drawn from the terminal piece of our angle to the x-axis, okay? And it's, again, this right triangle that we're going to end up creating here with that location. So if we just practice drawing in on page 194 these reference triangles, again, we're just going to take from this terminal angle here, or the terminal side of our angle, we're going to drop that to our x-axis, and we see we create these right angles. And for picture B, again, where that terminal ray is, drop in for the right triangle. And then if we are drawing again back to our x-axis, we're going up, creating this right triangle, and again back to the x-axis, creating that right triangle. Okay, always, always, always to the x-axis. That's one of the most common mistakes with drawing your reference triangles. Okay, now looking here at 15 then, what are we doing with these reference triangles? Well, the location of our point can help us determine how long each piece in the triangle is. So in this case, they want us to find OP. This is what we're looking for part A. Well, if we are at 3, 6, we had to move to the right 3 and up 6 units to get point P. And since we drew in this right triangle, we can use our old pal Pythagorean theorem, a squared plus b squared equals c squared, in order to find that length. So 3 squared plus 6 squared equals c squared. So 9 plus 36 is 45. And if we square root that, it breaks down to be the perfect square of 9 and 5. So aka 3 square root 5 would be the exact length of OP. Okay. Now, when we have a negative, the nice piece with Pythagorean theorem is when you square something that is negative, it turns into a positive. So again, if we're looking to find OP, again, it's not going to really make a difference that we move to the left 4 and up 3. But you still want to take that into account that it's a negative for future problems. You'll see why later. But 3 squared plus 4 squared, I like to put parentheses in case I type this into the calculator, equal that hypotenuse squared. And so we have 9 plus 16, which is 25, which leads us to our perfect square of 5. So that is OP's length this time. Okay. Now, of course, with Pythagorean theorem, we can also work backwards. And again, here you want to be aware, this is where the idea of this negative comes into play. This time they're telling us OP is 6, and then we moved X amount of units and down 5. So you want to be careful here because officially you moved to the left X amount of units. So that's going to become important to us eventually, that we are going to be negative with our answer since we moved to the left. But again, with Pythagorean theorem, c squared equals a squared plus b squared, that negative is going to be positive at this moment. So we have 36, and then we have 25 that we're going to need to subtract away. So our x value is the square root of 11. But again, because we moved to the left, we have to be careful because the location is actually a negative to fit into this location here on our graph. All right, now looking here at then the next page, we bring back our idea of trig and our good old pal SOHCAHTOA, right? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then their reciprocal functions, which are just the flip of that. We'll definitely get more into that later, but sine and cosecant are buddies, cosine and secant are buddies, and then cotangent and tangent are buddies. Okay. Now, using this information, we can have a little different kinds of information than just side lengths in order to be able to solve. Now, they are telling us that we have these reference triangles, right? And each time they're telling us that we are at a certain location. And in this case, we are going to write these in since they are in these first quadrant each time. Here is what they're telling us, right? Because in this case, we move to the right 3, and then we're going up y units. So we have to be careful here. Right triangle. Our theta means that we have a 70-degree angle here. And then again, we move to the right 3, and our y is what we are looking for. So drawing the picture is going to be really helpful for us this time. Now, going back to our SOHCAHTOA, we are given theta, and we are looking for the opposite side, and we have the adjacent side. So this is going to be an example of using tangent. So tangent of our angle measure equals opposite over adjacent. And then in order to solve, we have to multiply both sides by the 3. Now, right now we are given degrees. So we want to double check and make sure that our calculator is in degree mode. So make sure you hit the mode button and scroll down. Currently I'm in radian, and I need to make sure I am in degree in order to make sure that this answer will come out right. Because anytime you use sine, cosine, or tangent, degrees versus radians matter. So in this case, we have 3 times tangent of 70, which gives us an answer of about 8.242 as our y value. So y equals 8.242. Now our next one is asking us to look for the location of P. This time we have a 38-degree angle. So again, quadrant 1 here. 38 is our theta. And we are looking for the location here of P. OP, the origin to point P, is 20 units, and we want to find both X and Y this time. Okay. Now in this case, what we're going to do is again look at what we're given. We're given our theta, we have the hypotenuse. So to find the X value, that is the adjacent side to 38. So we're going to set this up with cosine this time because we have adjacent over hypotenuse. So cosine of theta equals that adjacent over the hypotenuse. So again, to solve, we would need to multiply both pieces by 20. 20 times the cosine of 38 degrees is 15.760. Now, to find y, that's our opposite side. So if we have the opposite in the hypotenuse, that's a sole portion, aka sine, which again of 38 degrees is going to equal our opposite side over the hypotenuse. So same process here where we're going to need to multiply by the 20. And in this case, 20 times sine of 38 degrees is 12.313. Now again, that final answer is asking us to put this back into the coordinate form, right? We're looking for the coordinates. So x, comma, y, this is the location of our point. Now we also can use this format to help us find theta. If we're at 6, 6, again, that's to the right 6 and up 6. So we're in quadrant 1. And if we're looking for theta, and we have the opposite and the adjacent, we're going to use our pal tangent. And we're going to set this up 6 over 6, opposite over adjacent. Now, anytime you need to find theta, you're going to use the inverse. Anytime you're looking for the angle measure, you need to use inverse. So in this case, we're going to take second button and then tangent to get that inverse. 6 x, we end up with a 45-degree angle for theta. And then last but not least, they're finally giving us one beyond quadrant 1. We're at 220 degrees. Now 220, a reminder, is all the way over here in quadrant 3. So here's 220. Now reminder, when we draw this in, our reference triangles are always in reference to our x-axis. So when we draw this back, yes, this is a 220-degree angle all the way out here, but really our theta measure is not 222. It's too big for our triangle. It's that difference between 220 back to 180. So really this is a 40-degree angle, okay? Now this time OP, they're telling us, is 12. And if, again, we're looking for the coordinates, x comma y, we're going to need to use a combination of sine and cosine because we have the adjacent and the opposite and the hypotenuse. So to find the x value, it would be cosine of 40 degrees equals the adjacent over the hypotenuse, and then the sine of 40 degrees is the opposite over the hypotenuse. Okay. And so from here, if we type those in the calculator, so again, multiply on this one, we're going to need 12 times the cosine of 40 and 12 times the sine of 40. We get our two values of 9.9192 or 3 if we round up, and 9.193, and y equals 7.713. Now we have to be careful. This is not our final answer because remember what quadrant we're in, 3. And also remember what that means about these x and y values. They're negative, okay? So the important piece here to remember is our final answer is actually going to be negative because we have to move to the left and down versus the right and up. Okay. All right. So again, sine is very important. Sine as in plus or minus sine, not S-I-N. Because of the quadrants you are in, right? Your x values and your y values when you're looking for location will be dictated by that, okay? We will definitely be working with more practice on this in class. Thanks, everyone.